Hi, so our group will be looking into bicycle accidents. My name is Caroline Morley.
Rachel Cooper.
Megan Cree.
Delaney Brown.
Right. So this data set details the conditions of various different biking accidents throughout Great Britain from 1979 until 2018. The data has 14 variables, 4 numerical and 10 categorical. The number of observations is 827,861. This data set contains data such as the accident index, number of vehicles involved, number of casualties, date and time of accident, speed limit, road and weather conditions, day of the accident, and finally, the road type in which the accident took place. In addition, it includes the gender of the person driving the bicycle, the severity of the accident, and the age group ranges of the victims, which we then changed into a numerical variable. Biking is a well-known and popular form of exercise. It is also a recognized professional event in world competitions and the Olympics. It is especially popular in Europe, and it is common to see many college students biking around Charlottesville as well, either to class, for fun, or for exercise. However, it is common to hear of biking accidents, even in a college town like Charlottesville. So we are interested in drawing conclusions that could give us insight on how to reduce the risk of danger, as well as any interesting correlations that may appear between the conditions. We'll first begin with data cleaning and summary. The first step in preparing the data was to combine the two different data sets the data came from. The two were naturally joined together on the unique identifier of the accident index variable, which was then dropped. In order to make analysis easier later on, the date variable was replaced with a decade variable, and the range of the victims' ages was replaced with a single numerical number in order to be able to get numerical information from such an important factor. There was a lot of missing data, but instead of NA values, they were labeled as unknown. So in all the columns, the unknown values were replaced with NA, and then the rows with NA values were dropped. We deemed this okay because our data set still had a large number of observations even after dropping rows. Lastly, subsetting and filtering that was specific to certain exploratory functions was done later on. The resulting age variable and decade variables are demonstrated below to show the results. To summarize the data numerically, several important key variables were summarized by categorical groups. The average age of the biker in the accident was calculated for each gender category. On average, older women seem to have biking accidents. The average number of casualties was calculated for each different type of road condition, and it seems to be that generally the average number of casualties stayed around 1 for all conditions. Lastly, the average speed for different road types was found, and the speed is the highest for dual carriageways, which is a road with a median strip between the traffic in opposite directions and typically 2 or more lanes in each direction. It makes sense for it to have the highest speed since there's such high traffic. In addition, a 5-number numerical summary was found for all the numerical variables. The averages for the number of vehicles and the number of casualties was around 1 for both, which is very reasonable with such a large amount of data. In addition, the standard deviation was found for each, and the highest deviation variable was found to be the age variable, with the speed limit being the second highest. This is reasonable because in the real world, there's a lot of fluctuation in these variables just depending on the road and the person. For the categorical variables, using an apply function, the tables of the counts of each category in the variables were found. Here are the counts for the gender, road type, day, and road condition variables. As we can see, there is good balance between the counts for each category. The slip road count in the road type is slightly low, and the flood count in the road conditions variable is slightly low as well. This could be a result of them not occurring a lot naturally or from the data collection itself. Here are the counts of the severity, decade, light conditions, and weather condition variables. As we can see again, there is a good balance between the counts for each category. The snow and windy count in the weather conditions is slightly low, and the fatal count in the severity variable is slightly low as well. This could be a result of them not occurring a lot naturally or from the data collection, just like the others. Lastly, two-way tables were created between various different key variables. According to the severity and gender two-way table, there were many more male fatal accidents, but that could be due to the data gathering, as the male category had a high number in all 3 severity categories. In the severity and weather conditions two-way table, the majority of accidents occurred on clear days, which makes sense because generally bikers might not want to bike during bad weather. In addition, the second highest weather category for fatal severity is rain, which also correlates with what is expected. Lastly, the road type and decade two-way table demonstrates that certain road types did not exist in the past before the 2000s. This is important to keep in mind when interpreting the conclusions drawn with the road conditions variable.
Now we're going to move on to data visualization and our graphs. In this bar graph, we wanted to determine the number In this bar graph, we wanted to determine the number of bicycle accidents that occur each day of the week. On the x-axis, each day of the week is shown, and on the y-axis, the number of accidents pertaining to that day of week is measured. According to the bar graph, accidents occurred less on Sundays. On Tuesdays, Wednesdays, Thursdays, and Fridays, accidents appear to have taken place an equal number of times. Based on this graph, it seems that there are less bike accidents over the weekends in comparison to the weekdays. This could be the result because bikers are on the road less over the weekends, or weekend bike riders are more cautious than weekday bike riders. To further explain the bar graph, it appears that there is a relatively normal distribution among the occurrences. In this bar graph, the x-axis shows the road conditions, and the y-axis gives us the number of accidents per road condition. This graph shows that bike accidents occurred the most when the road conditions were dry. The second most frequent road condition for bike accidents was when the roads were wet. Bikers were most likely less willing to ride when conditions were snowy, frost was on the road, or flooding occurred. In terms of this histogram, it appears that ages of bikers and accidents occurred most frequently between the ages of 10 and about 22. It is also interesting to note that the histogram is skewed to the right. This could be true because there is a higher likelihood that younger people are going to be more reckless while riding bikes in comparison to older people. This box plot shows the speed limit and the number of bikers in those speed zones. Because of the high number of occurrences in bikers and accidents, we have a small range for the speed limit. The box plot does not clearly show the 5-number summary, once again because our data set included many values. In this graph, we wanted to compare two categorical variables, gender and severity of the bike accident. Generally, bike accidents seem to be labeled slight in all instances, with few fatal or serious accidents. This box plot compares the 5-number summary of speed limits for each road type. In the dual carriageway and slip road, the range of speed limits is larger, with fewer outliers in comparison to the other road types. And then to explain what a dual carriageway is, it's similar to what we call a divided highway in America, and there's 2 lanes on each side. A single carriageway is an undivided highway with 2 lanes, both going in opposite directions. And then a slip road is similar to a ramp, and it's used to merge onto a highway. There does not appear to be any correlation between number of vehicles involved and the number of casualties in each accident. However, there were generally no large number of fatalities in the bike accidents overall. This graph is similar to the previous, but we wanted to relate the graph to the light conditions and speed limit in each. This bubble plot does not show any specific trend or correlation either. It seems as though most casualties occurred during the daylight hours. Further, the darkness with no lights variable is the second most occurring variable in the graph. According to the time series graph, the severity percentage of accidents in each decade were relatively similar depending on the road conditions. One variable that did change slightly over the course of the decade shown was the frost variable. This could be due to the technology of the roads increasing over the years in Great Britain. Lastly, for our data visualization, we created a heat map. According to the heat map, on each day of the week, accidents were less likely to occur with no vehicles at earlier times in the morning, which is shown on the left side of the graph. On certain days of the week, like Sundays, vehicles were on the roads much later in the day. Like our other graphs, the data is also difficult to interpret because of the high number of occurrences that were included in the data sets.
So now moving on to inferences, we started first with a one sample confidence interval proportion. And so our question was looking at what proportion of biking accidents occur on Saturday. And we specifically chose Saturday because we thought it would be interesting. It's typically a different type of biking because Saturday is more seen as more of a leisurely day. And so people aren't necessarily biking to work or to school. Instead, it's for fun. So we thought that this might lower the chances of an accident. And we found this by doing a table where we looked specifically how many accidents occurred each day of the week, with finding that 71,150 occurred on Saturday out of a total of 643,467. And so then by using these two numbers, we did a prop test at a confidence level of 0.95. And we found that we are 95% confident that the true proportion lies between 10.98 and 11.13%. And this is interesting because 1/7 or like an average is 14%. And so that shows that typically less accidents are happening on a Saturday than you would expect. And so now, again, doing a one sample confidence interval, but this time looking at mean, we asked the question, what is the average speed limit of the road where an accident occurs? And we found this by doing a t-test, looking specifically at the speed limit of the data at a confidence level of 0.95. And we found that we are 95% confident that the true mean lies between 33.51 and 33.56. And this is really interesting because this is the lower end of our speed limits. And you would maybe expect it to be higher because it could be more dangerous for a biker to be riding on like a 60-mile-per-hour road. But this just goes to show that bikers probably know it's more dangerous to be around vehicles going that fast when they're unable to keep up. So typically more of the accidents happen on these lower speed limit roads. Okay, and so now moving on to two sample confidence intervals. This beginning first with proportion again, we asked what is the proportion of accidents that are serious for 70-year-olds versus 10-year-olds? And we picked these two values because we thought it would be interesting to look sort of at the bookends of our data because the 10-year-olds are our youngest data points and the 70-year-olds are our oldest data points. And they're both sort of seen as fragile in their own way. And so we thought it would be interesting to see if that affected how the accidents occurred. And in order to do this, we first did a table similar to the one sample, but this time we looked at both severity and age group. And we found that in the age range of 10, there were 64,479 accidents, of which 11,030 were serious. And for the 70-year-olds, there were only 14,676 accidents, but 3,880 were serious. And so in order to find this confidence interval, we did a prop test with these two sets of values at a confidence level of 0.95. And so as you can see, the confidence limits are both positive. And so this means that the 70 age range will have a higher proportion of severe accidents by a number within the confidence interval compared to the 10-year-old age range. And we are 95% confident that the proportion of severe accidents in the 70 age range is between 8.6% and 10.1% higher than the proportion of severe accidents in the 10-year-old age range. And that's a pretty big percentage difference. And that could maybe account for the fact that 10-year-olds are maybe with their parents who are making sure they're being more careful when they're with these accidents. And 70-year-olds might still think that they're more able than they are at that age when 70-year-olds are typically more fragile. And lastly, we have another two sample confidence interval, but this time looking at mean. And we asked, what is the mean number of vehicles involved in a biking accident for females versus males? And for this question, we actually had to manipulate the data a little bit and create a new data set where we took out some of the values where gender was other because we wanted to look specifically at males and females. And this allowed us to do a two sample. And so then we did, after we took out these other values, we did a table looking at the genders, looking at how many accidents were for each gender. And then we did a t-test for the number of vehicles in this new data set, which we called gender, at a confidence level of 0.95. And as you can see here, both values are negative, which shows that the mean number of vehicles involved for female bikers in accidents is less than that of the male bikers. And we are 95% confident that the true mean number of vehicles involved for female bikers is between 0.007 and 0.010 vehicles less than male bikers. And that sounds pretty minuscule because those numbers are so small. But with a data set this large, what that means is that typically still males are more likely to get into an accident involving more vehicles, which typically means it's a more serious accident because the more vehicles involved, the more likely that someone could get injured or that it's on a bigger road. So this just shows that males typically get into more dangerous accidents than females.
All right, so for our regression, we first did a simple linear regression due to the fact the data set was so large that a multiple regression would have not been possible. And so an equation was created to demonstrate the relationship between speed limit, which was the independent variable, or x, and the age of the victim, which was our dependent variable, or y. And so the resultant equation that the model built was y equals 23.55 plus 0.14x. And so what this means is that for every 1 mile per hour increase in the speed limit, the age of the victim increased by 0.14 years. And in this case, our y-intercept was 23.55. And from the multiple r-squared value, we were able to determine that about 0.68% of variability in age value can be explained by this simple linear regression model. And for the adjusted r-squared value, this demonstrated that the model had a 0.68% predictive power. In terms of prediction, we used a reasonable value of 40 miles per hour for speed. And we used the predict function with an interval of predict. And with these results, the interval of age values ranged from the lower bound of negative 2.55 to the upper bound of 61.03, with the fit or actual predicted age with this value for speed as 40 to be 29.24 years. So for our logistic regression, according to the data set, values for the variable of gender were either male, female, or other, but like we said earlier, we decided to focus on male or female due to just the sheer amount of values for these two categories, which made the variable binary categorical, which is why we chose to do logistic regression. So we wanted to find the best predictor variables for gender in bike accidents to observe any trends that we could. And so a new column called G was added to the dataset via dplyr, designating the male values as 1 and the female values as 0. And the predictor variables that were selected were number of casualties, speed limit, and age group, as these were all numeric variables. And so the logistic regression model was built with the GLM function, the mass package, the step AIC function, and the exponentiation function. And after applying step AIC, the number of casualties variable was eliminated due to the fact that practically all of the values in the data set had 1 as the number of casualties, which would make number of casualties not a great predictor of gender. And so the resulting intercept from the logistic regression model was about 3.72, and the coefficients for speed limit and age group were 1.01 and 0.99 respectively. In regards to speed limit, this means that while holding all of our variables fixed, for every additional increase of 1 mile per hour in speed limit, the odds of the victim being male increased by about 1%. And in regards to age group, holding all other variables fixed, for every increase of 1 year in age, the odds of the victim being male decreased by about 1%. And to continue our logistic regression, we wanted to make a prediction. So we wanted to use interpolation to look within the data to make a prediction about the gender of the victim being male. And so the reasonable values used for the predictor variables were 40 for speed limit and 35 for age group. And so a new data frame was built with these values, and the predict function was used to predict the probability of the victim being male with these values. And so with the resultant value of about 0.81 from this prediction, that means that there's about a 81% probability that the victim was male given the 40 miles per hour value for speed limit and the 35 years for age group.
So here we have our list of references, and we just wanted to thank you so much for listening to our presentation. And while this data definitely came with its challenges, it was still really interesting to analyze, and I hope you had as much fun listening about it as we did coding for it.